Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we are going to be viewing spatial results from a HMS simulation. All right, what I have in the description to this video is the link that you should visit first to download the files. It's on this page right here, viewing spatial results for structured discretization. So what we're going to do is we have three separate zip files to download. So the instructions tell us to download all three. I'll click the first one and then wait for that to download after I click the download button. So it's downloading. Okay, so that one's downloaded. I'll close that. Next is the data.zip. Click download. Okay, that one's done. Close that. And the last one is this gis.zip file. So I'll download that. Okay, and we're done. So let me close that. And then what the instructions say down here is that we need to unzip the GIS and data directories and put that into the main project directory, which is called main stem Columbia. So I'll just go ahead and do what it says to do. Here, I'm going to find the location I want to put these files in. It's exercise 11 in project. Okay, I'm going to drag the main stem Columbia.zip file right here. Open that up. I realize these are the files that I want inside my project directory. So main stem Columbia is the project directory. In this case, I'm just going to right click and extract all, and then it's just going to put it right there. So I'll click extract, wait a moment, and that's done. So this is my project directory, but I don't have a directory here for GIS or for data, and that's what I need to unzip over here. So let me just go up a level real quick, delete the zip file before I forget. Go back in here. Now I'm going to select the data.zip, and I'm just going to drag that over here. That's unzipping. Okay, there's that. And then the GIS is right here. I'll drag that over. Okay, that's good. I'm going to close these and then don't need that anymore. All right, yeah, the instructions say don't try to open up this project before the data and GIS, our folders, are added in. That makes sense. All right, let's go ahead and open up that project. So HMS, and then open, browse, and then navigate to that project. So here it is, main stem Columbia.hms, select. So right now I got a warning message that says that the selected project is from version 4.10, and I'm using 4.12 right now. So there's going to be a conversion process, and I won't be able to use 4.10 files again. That's fine. I can always download them again. So convert project, open. So it looks like we're open here. So I've got a basin map, and that's coming up here on the screen with a watershed that's been delineated. We have reaches, we have terrain data, all sorts of hydrologic elements we can see, as well as a meteorologic model control specification. So I'm just kind of zooming around and seeing what we got here. The control specification for this simulation is from October 2nd to June 1st. So about 8 or 9 months at a 3-hour time interval. October, November, December, May. Yeah, 8 months. The good thing about this project is we don't need to go into the details of setting up the requirements for the simulation run. All we need to do is run the simulation and just focusing on the spatial results and some of the features. Some of the spatial results requirements are that the subbasins are georeferenced. If the subbasin discretization is structured, then the results will display on the SHG or UTM grid. If it's unstructured, then the results will display on a 2D mesh. And then if it's file specified, it will be displayed either at the subbasin level or the grid level. So let's go ahead and click on one of my subbasins right here. I'm going to zoom in on this one selected subbasin. And then over here in the components editor, we have a discretization method for structure that's been selected. And then if I select the discretization tab, then I see the details here. It's a 2000 meter cell size with a SHG projection. I can also check out which discretization is used by all the subbasins. If I go up to the parameters menu here and then select discretization, I can see that they're all selected as structured because there's unstructured and file specified or grayed out. I don't have the option to even click on those. But if I click on structured, I need to remove the filter. Okay, I can see all the subbasins here. It appears they are all using the SHG projection with the same cell size. In addition to the subbasins requiring a specific discretization method, the spatial results on a grid basis also require that the simulation is run using either the Mod-Clark or the 2D diffusion wave transform method. So Mod-Clark is what we have selected here. So that's good. I'm kind of skipping ahead to step 3 here, but if we go to the Watershed Explorer and then the Compute tab right here, and then click on Simulation Runs, and then click on our Spatial Results Simulation Run right here, we also need this Spatial Results Yes value to be selected before we run the simulation. So when the simulation is running, this needs to be set to yes. And then the spatial interval here is 3 hours. I'm going to actually change that to 1 day and then click save. Okay, now I'm going to back up to step 1. So if you're following along on the website, the tutorial page where we downloaded the files, step 1 tells us to select the GIS menu up here and then select pre-process drainage. So I'll go ahead and do that. This will compute the flow direction and flow accumulation grids. This info is needed if the modeler changes the grid later on. I'm going to zoom out real quick to see more of the subbasins. And then if I click on View and Map Layers, we can control which layers we see and don't see right now. I just finished running that pre-process drainage step in the GIS menu. And that's why we got these 2 new layers for flow direction and flow accumulation. Let me go ahead and just toggle off some of these layers. So this is flow direction. That's a pretty one. You can zoom in and just kind of see the direction of flow by the color. I zoomed out a little bit. I'm going to turn on discretization. There we go. So now we're seeing the cell size. And this is the same grid cells that we're going to see later in this exercise when we're actually viewing the spatial results on a grid basis because we're using that structured discretization selection. Let's turn that off. Sometimes if you have too many layers on, then it takes a while for the map to render every time you zoom or pan, and I don't really like that. The next step is step 4. That's to run the simulation. So I'm going to go here to the Compute tab, and then I think everything's ready to go. We have the simulation run selected up here, and then we can just go ahead and click to run. So again, this is a 8-month simulation run with, I believe, a 3-hour time step. And then we're capturing the spatial results at a 1-day time interval. So here in the simulation run progress bar, we see the start date time, the end date time, and then the current date time here. So as you can tell, this is probably going to take a couple minutes. Okay, it looks like our simulation has completed, so I'll click close there. Step 5 is on the spatial results toolbar, we need to select our variable. Now, right now, I don't have the toolbar up and running, so go ahead and click View, and then Toolbars, and then Spatial Results. So I don't have a checkbox here, which means it's not up. When I click that, boom, here is my spatial results toolbar. All right, so here's the variable, spatial variable that I can select. I've got a number of options here based on all the data that's in the model itself. I'm going to select SWE for snow water equivalent. And what it's asking me here is it needs to calculate these animation tiles. This is a one-time calculation or generation. And I'm just going to go ahead and say yes. The instructions say that this will take a couple minutes. Okay, so that completed. So I think we're ready to look at some data. I'm going to zoom out so I can see the full watershed. Drag the animated slider to December 19th, 1996 to view the accumulated snow water equivalent at this time. You can view the snow water equivalent grow throughout the year by playing the simulation. So let's see, here is the variable snow water equivalent. Here's the slider bar, and then here's the play button and some of the other controls. So if I just slide this over, we can see the colors change on the map. So December 19th is what the tutorial tells me to put it at. What we see on the map now is some blue and white coloration on top of our generic green for every subbasin. Now we have a lot of different options in this settings button right here I wanted to demonstrate. The first tab is playback, and I like to uncheck the loop animation and slow the animation down. Right now it's at 24 frames per second, which is, 1 a day, so 24 days per second. Let's change that to 10 and then click apply. The next tab over is symbology. So this is going to ramp up from white up to dark blue. The display tab is one that I almost always change, and I like to change the transparency down to a lower number than 0.5, the default, unless I have a good reason to do otherwise. So hopefully if I rerun it, we'll see a slower and then less transparent color representing that snow water equivalent over the simulation. So let me go ahead and click play now. So we're October 1st. Now we're on to November 1st. December and January is when we had the most snow, I believe. So there's January and then February and so on. I'm going to pause the animation and then zoom in on some of this data. right up near, yeah, right here happens to be a mountain location. And if I hover over, I see the snow water equivalent right there is 89.41 inches. And then if I come over to another location, 13, and then over here would be 0. If I want to know what the time series is of any specific cell, rather than just the value at the selected time, which is March 2nd, 1997, right now it's 16.14. But if I right click, plot spatial results, now what I see is a plot that shows the snow water equivalent over the course of the simulation. So it starts at 0, of course. It goes up to about 16 or 18 or 19, and then it kind of stays there for the next 3 months, and then it drops back down. I can do the same thing at any location, even if it's currently 0. So there's a little bit of snow water equivalent at this location, but it looks like it all left by February. One thing to help me get the view the colors and know what they mean is to go up to view and then select. That will put the legend of the coloration right down here in the corner. I'm going to go ahead and change those values again. So for symbology, let's go ahead and change it to just 100 and then apply here. Okay, let's run back the simulation and view the entire watershed. Now, if it's more than 100, I believe it just defaults back to green and then play. Another option is to not select stretch, but rather classify. And in this situation, we can now set the number of classes. And let's go with 4. And now if I select the range from, say, 0 to 100 inches, and then click apply, now those numbers automatically populated in this lower table. So I'll click apply there. And now we have discrete ranges of colors. So it looks like we might need one more range that's above 100. So I can go ahead and maybe go manual as another option. So instead of over 100, I could change this to, what was it, 160? I'll just say 170 to be safe. Get the label here as well. That's used for the legend, I presume. 170 here. Let's just click apply and see what happens. Okay. All right, good. Now that it's colored in solid blue right here at the mountaintop. I'm pretty sure this is a mountaintop right here, but to confirm, I'll go view, map layers, and then I'll turn on that terrain layer, close this, change this to, yeah. So we have definitely a higher elevations right here. All right, let's run the snow water equivalent one more time and play. So this is the discretized into 4 different regions of the snow water equivalent based on this legend in the bottom right corner here. So that's January, February. As spring and summer begin, we have less and less snow water equivalent. Step 10 in the tutorial tells us to change the spatial variable to something different. We have other options here. How about air temperature? And then I'll just go ahead and play that simulation. So we're in October. Now this is November 1st until it's getting colder. It's December 1st. We're moving into the blue and even purple range, January 1st, and that's February 1st. And then now we're starting to warm up. It's March 1st. We should see some greens and yellows, April 1st, and so on. One thing that I don't like about this temperature range, it goes up to 100, but when inspecting an individual cell, I never found any temperatures that got above 70. Well, of course, this one proves me wrong, but usually it ranged between 5 degrees and 65 degrees for most all the cells that I looked at. So what I'm going to do is just change this maximum value to 70 and then apply and apply. And I think we should have a little bit better temperature range. Okay, let's go ahead and see what that looks like now. So this is temperature, it's November, and then this is December 1st, and now January, and so on. Okay, so that was the first task. If you scroll down on the instructions towards the end of that first page, there's another task for viewing calibration results. And the step tells us to select the variable flow-NSE. Now this refers to calibration data, where the higher the calibration number, that's closer to 1, the better the calibration score. And then lower scores like less than 0.5 or worse calibration scores. So if I hover over the map, I can actually view what that calibration value was. Right here in red, we see 0.25. So that's a fairly poor calibration score. But down here in green, if I hover over, it's 0.833. Now these scores are for the entire subbasin, not the individual grid cell. But it does give us a quick way to identify which areas of the map, specifically which subbasins, need help with their calibration parameters to bring those scores back up to whatever the acceptable range is. So that's it for the first page of instructions. The description of this video has a second link, which I invite you to click on. In this second page, we're going to talk about HMS animation export. This is really just a continuation of our discussion of spatial results, and it will be pretty quick. If you're on the first web page, you can also just click this link, HEC HMS animation export. It's just below the page that we were on, but still within the spatial results tutorials. So I'll go ahead and click that. What you're going to see at the top of the page is another zip file. So you're welcome to download that zip file, which is a project which you can unzip and then open up and use for spatial results. But you'd have to go through a few more steps, like running the simulation again. So I'm going to skip that step and just use the project we already have open for this last part of the exercise, which is animating the export, basically creating a video, an MP4 file of the simulation so that we can easily share it with others. So here's the introduction. What it tells us to do is check that the discretization is structured for all of the subbasins. We already did that. Steps 2 and 3 tell us to run the simulation. So if you're downloading the files from this page right up here, you will have to do that, but we don't need to do that if we're sticking with the same project. Step 4 here is to select the cumulative precipitation for our spatial results. So let's go ahead and do that. I'm going to come up here and then select precipitation cumulative, and then let's go ahead and run the simulation. So we see over the course of the 8 months, we have more and more precipitation. This little red icon here is what we click on to start the recording, and then we would click it a second time to stop the recording. So let's go ahead and do that. I'm going to go ahead and just back up the simulation to the beginning. Click the play button, and now we can click this video icon. So I'll do that now, and then I'll just let it run for a moment, and then I'll click it again. Now it's stopped the animation and it's asking me for where I should save that MP4 file. So I'm just going to go ahead and browse to my desktop. I'll just call it animation1.mp4. Okay. Export, and then okay. And then here it is right here. So it's just a saved MP4 file. And then now I'm playing that video here in my video player. So we can just see how the colors change and basically what was on our screen. Well, that's the end of the exercise. In this exercise, we downloaded a completed project or almost completed project. We ran the simulation. We made sure that spatial results was turned on. And then we looked at some of those spatial results and modified the playback controls and the symbology.